This lesson is going to be about graphs and trend lines and learning to be able to use trend lines to analyze and interpret data. So we talk about trend lines, and what a trend line is a trend line is a line on a graph showing the general direction the group of points seem to follow. You've probably heard about it as a line of best fit. And so anytime we take a scatter plot, we can take and we look at this data and we kind of have an idea of what the data is doing. And if I was going to draw a line of best fit or a trend line through this data, I'm trying to draw the line that I guess best fits with this data or shows the trend of this data. And so if I was going to do that, drawing a straight line right through here, I might do something like that. I can see that I've got some of my numbers or my data points are above this trend line, and I've got some that are below the trend line, and I try to meet all of those in the middle to best show where this data fits. Now, it could be a straight line, but it also could be a little bit different. That first example was pretty straightforward with what that looked like, but we could have something where this data seems to be following a different type of pattern. Could have more of a curved line here. So my trend line might have to move in order to accommodate the pattern that's going on in here. And I could even draw something a little bit closer. I just saw that. There's probably, maybe that one fits it a little bit better. I could have something through here. Now I'm just having fun trying to draw the best trend line I can. but you see what I mean is that this trend line doesn't have to necessarily be linear is what we would call it, a straight line, but it's going to show the general direction that a group of points seems to follow on a scatter plot. And we're going to go into some different patterns that these trend lines can take. So the reason why we use trend lines is because they allow us to understand the pattern in our data, or if there is a pattern in our data, or if we don't have a pattern in our data, they're going to allow us to see that we don't have any sort of a pattern that trend lines can show us in our data. And it helps us to identify the relationships between variables. And so in an example for this data here, we can see that the relationship is as x increases, as my temperature increases, my y, my sales also increases. And so we would know that um, that is a pattern, that's a relationship between x and y that we have in our data set. We can also look at this in a little bit closer in with our data. We can see that as x doubles, y also doubles. As I see that I start off at 2 and 2, as I go to 4, my y roughly doubles. As I go to 6, or as I go to 8, as I double my x, y also doubles. So we can see a mathematical relationship between our data points because of our trend line, a mathematical pattern. And we can see, you can also note that I have an equation for this trend line. So we could actually plug in a number of x, something like 4.5 or 4.6 or 4.7 or whatever, and we could find out what our y is because we have a trend line with that. So we can find the mathematical relationships between our data. And we can also see a different type of relationship. We can see that as x increases, y increases exponentially. And so we can see that right here, we're not getting a whole lot of change for every value of x, but as x increases, our y is changing more and more. We go from right here to right there. This one we go here and go there, and then here is our change that we're having. And we can see that over time, our y is increasing by more and more. And this is a very important relationship to be able to see, is that y doesn't linearly correlate with x, is that it's a different type of relationship. And so with trend lines, they're going to help us to identify what's going on in our data so that we can understand better how this data really applies to a real life situation. So we're going to go through these patterns that our data can take on. So as we look at the different types of trend lines that we could possibly have, I did pull off of Google Sheets. These are the options that you get when you do a trend line on Google Sheets. But the first type of trend line that we could have is a linear trend line. This is a pretty simple one. And anytime that we can model our data off of a linear trend line, when that fits our data, we want to do that because it's a simple model for us to use. And so that's just going to look something like a straight line going through. A possible equation, if you've ever heard of y equals mx plus b before, that is the equation for a line. And so that's going to be a really useful piece of information that we can have anytime that we can model our data off of a linear data set or a linear trend line. And so when we have, we could also have something like an exponential, like we showed in the last one. This is when something rises or falls at an increasing rate. This could look like when it starts off very slow and then very quickly speeds up. It's not going to go backwards, but it will speed up really, really quickly. And a graph that we could possibly have, or an equation that we could have for this, is y equals x squared. So as our x increases, our 2 in this case is being multiplied by itself more and more times. And as that number gets higher and higher, um, our y increases exponentially for every value of x. So we could also have that exponential. We could have a polynomial, and this is a curved line for when data fluctuates. And this becomes important if you get to really complicated data sets. If there's going to be another type of trend line that we can use that we will be using that is a little more simple than a polynomial. But a polynomial could look something like this. It could look something like this. It could look something like, then go back down. It could look something like this. But that polynomial is going to be able to give us a lot of different equations depending on what our data is doing. And so a polynomial is also one type of trend line. And we'll show the similarities between that and the power series, which we'll get to in a couple here in a second. So another type that we could have that we're really not going to talk about a whole lot that you'll see on Google Sheets, but we're not going to be using this one with what we're doing here, is a logarithmic data set, a logarithmic trend line, and that's when data changes very quickly and then levels out. This could look something like comes up and then levels out like this. That's what you're typically going to see when you're on Google Sheets and you're looking at that one. You can play around with it, but that's really not one that we're going to study too much. It doesn't really fit with what we're doing. And then the last part here, and this is the one that is very similar to a polynomial, is the power series. And this shows that when data changes at a specific rate, you can see that it is going to be a curved line. It's going to look something like this, probably not as steep as an exponential. But you can see the similarities between this and the polynomial. Polynomial is y equals x squared plus some type of x. Let's just say it's 2x plus 4. And a power series is y equals 2x squared. And you can see this first part here. Those two are very similar. You still have that x squared. And so sometimes you're going to see that a polynomial and a power series will fit your data very well, and they'll both fit it about the same. And so just be careful of that. But those are both two types of curved trend lines that show when data changes at a specific rate. And then as the data starts to fluctuate more, we get the polynomial. But these are the main types that you need to be able to recognize and be able to find on Google Sheets. And those are the types that we're going to be using in your activity a little bit later. So as we're trying to figure out which type of trend line fits our data the best, we've got to be able to ask, how do we know if we picked the right one? And there is a way of doing that, and that's called the R-squared value. We know that when the R-squared value is close to 1, our data is a good fit, or our trend line is a good fit for our data, I should say. And you can see that this data set right here has an R-squared value of 0.984, which is a good fit for our data. Essentially what the R-squared is doing is it's taking how far away all of these data points are from the trend line. And without getting too much into the detail, the closer they are, the closer the R-squared value is to 1. And so you can see here, these are all pretty close to our trend line. And you can see that over on this one, we have our data points are far away from our trend line. And so our R-squared valued is much lower. It's showing the difference between the trend line and the data points that we have. And you can see that this data doesn't look like a very good fit. Our trend line doesn't look like a very good fit for our data. And this R-squared is really low. And so when you're going through this data that you're going to be playing around with, you got to look for making sure that you have the R-squared closest to 1. And then that's going to tell you which type of trend line you should use to fit with your data. So hopefully you have a better idea of how trend lines can be used to analyze and interpret data. You're going to be using those types of trend lines, whether it's linear, power series, exponential, or polynomial. and fitting those trend lines to specific types of data sets and then figuring out which ones work the best. And so I hope that this helps give you an introduction into the types of trend lines and how we can know if we use the best one.